Hey guys, Mr. Zanakis here. I just wanted to go over some of this data analysis with you in preparation for continuation and completion of your lab for this conservation of momentum here. So this is the first collision, the elastic collision, and I want to go over some of the points of the graph and how you're going to capture this data. So if you follow the directions, your red car was the one that was in the middle of the track, and you push the blue car. And what's nice about having these two graphs right over top of each other is that their timelines line up. So you can see the 2 seconds column lines up directly with the 2 seconds. So you're looking as things are happening almost as if they were overlaid with each other. And what this first spike here, again, slope of the line on a velocity versus time graph is the acceleration, is you pushing the blue car. And then a little bit of friction. Okay, even though it's closely frictionless, there is some friction and it is slowing down after you stopped accelerating it. Okay, so you can see that the velocity starts to slow down. And then right here, right around, I don't know, roughly 1.7 seconds, there's a dramatic change or another acceleration, a negative acceleration for the blue car. And at that 1.7 seconds, roughly, is right about when the red car, which was not moving, all of a sudden accelerates in the negative direction. And then you can see that there's a change and the acceleration stops, and then the red car and the blue car no longer are accelerating. Okay. In fact, the red car is still moving at this velocity, -5 and change meters per second, and the blue car has stopped moving, which is what you observed. Okay, so this acceleration is the time of the collision. This is the impact force that would make up the impulse. Okay, so how do I get these exact points and critical measurements that I need to be able to determine if momentum was in fact conserved through this collision? Well, up here in each box, right, depending on which one you're on, let's start with the blue one, there's a little yellow highlighter. And if you click on that, a little box opens up. And so what you want to do is you want to drag and make sure that you're catching at least a couple points before you can see the acceleration or the slope of the line. And likewise down here. And then I want to do the same thing, use the highlighter and capture right about there, and then change the aspect ratio, because this is the data that I want to make sure these critical points where the acceleration begins and stops is really my collision. So I want to analyze the momentum of the system, mass times velocity for each cart, before and after the collision. So the easiest thing, why highlighting it not only on the graph helps to see it, but it also highlights the data in the table form. Just makes it a little bit easier to find. You can see if you were off of that particular point, by highlighting it, it brings it right to the center of your table on the left-hand side. So the biggest indicator of the correct time immediately right before the collision or as the collision is about to happen is for the red car when it first starts to move. So 0, 0, this is to the -4th, again, 0.001, 0.006 is really the first part where I would say we probably have some movement occurring where now so the collision just happened right before here, okay? So if we would look at this at 1.7 seconds, that's when it first starts to move. I'm going to come up to the blue table here, 1.7 seconds, and we will find that the velocity of the blue car would be 0.517 seconds, okay, 0.517 seconds at that correlating 1.7 second time. So that would be the initial velocity of the blue car. Clearly, we knew the initial velocity of the red car is 0. Now, for the final velocity of each, okay, well, we can see that the final velocity of the blue car is 0. And when does this actually occur for the red car? Well, what's the maximum speed that it reaches? If I scroll down here, I can see 0.503 meters per second at 2.1. You can also come up here at 2.1. For all intents and purposes, that is 0 for the blue car, and 2.1 seconds is going to be the max velocity and speed for the red car. That's the highest it's going to be right after the collision stops. And as soon as those separate, you can see there's a little bit of friction that starts to slow it down. So the final velocity for the red car would be 0.503 meters per second, and the final velocity for the blue car in this elastic collision. Okay, it's very, very close, but conservation, as we know, is always conserved for these types of collisions. So you can analyze and look at that. And you'll also be measuring the mass of both of these carts tomorrow and the mass bar. So you have all the information you need to actually plug in the numbers and analyze it. Now, just be mindful that the fact that this is in a negative direction and the blue is in the positive direction for the direction it was traveling. But on your track, the blue car slammed into the red car, and the red car went in the same direction as the blue car. So why is this one negative and this one positive? Well, it doesn't actually, it doesn't matter with respect to the track, it's with respect to the car. So the orientation of the car and its own internal settings were determining which direction is positive or negative. So the fact that this velocity is negative, don't use the fact that it's negative in your analysis, okay? In this case, you have to set the frame of reference for the cars based on what you're observing, which is both cars are moving in the same direction, so both velocities would be positive. You can actually go into the settings and change the direction of what the car has predetermined what is the positive or negative direction, but it's really not that critical. Just understand the frame of reference is something that you want to set for what you have observed, whether the cars were moving in the same direction or they were going in opposite directions. All right, so that's the elastic collision. Let's take a quick look. If we added some extra mass, which is run 2, again, what you want to do is go up to the little symbol. It looks like the Google Drive symbol. There's a little black arrow. You can then select which run. So I'm going to look at the second run, and you need to do that for your tables as well. So run 2 and run 2. Again, you can see the push that is occurring here, slowing down. Here is the collision. Here is the collision. I'm not going to spend the time to highlight it again. Well, let me just go ahead and do that just to show you. Okay, highlighting tool, moving this over to where the actual collision is occurring. But notice here that in terms of the data interpretation, I'm not going to highlight down here as well, but this time there's extra mass in the blue one, and it doesn't go all the way down to 0. Okay, it has a different velocity than what it had before. And also notice the slope of these lines. I see a greater acceleration. The time of the collision is the same, but there's different accelerations because there's different masses. The forces between them are the same. All these same concepts that we've been talking about, you get to see this here graphically with the data that was collected by the smart carts. Okay, last one we're going to look at, see if I got this one correct, should be the explosion. So we can see what that should look like. Again, the Google Drive looking like symbol there. We're going to select run 6. And let's go ahead and change these to run 6. And what you can see now, this internal explosion is occurring. They're both at rest until the spring is released and that plunger explodes, applying an equal force to both carts. In this case, I don't remember exactly which run this was, but it looks like they have just about a little bit more than 0.8 meters per second. So they're just about the same. I'm going to guess this is where both carts do not have extra mass in them since the velocities are so similar. Okay, now in this case, with the internal explosion, this actually works out, right? I have a positive direction for the red and a negative direction for the blue. And that's fine because in the explosion, the carts actually go in opposite directions, in which case there you would want to take that into consideration because, in fact, on the cart, both went in the opposite direction from each other to cancel out their momentum. So we're looking for conservation of momentum. I hope this helps in terms of your analyzing. When you are taking what you should collect in terms of when you are submitting for your lab report, you know, highlighting this data and figuring it out. And let's just say that the collision is occurring, or the internal explosion for this one is right here. So I would say, okay, both of them had initial velocity of 0. We know that. What was the final velocity for the blue car? Well, the final velocity for the blue car was maximum, which was 0.867, which occurred at 4.55 seconds. So I'd want to write down and record both of these numbers. But I'm only going to grab a screenshot of just the graphs. You don't have to grab screenshots of the tables, just the graphs. So again, I want to write that down and then share that with the rest of my group. And I'll do the same for here. That was at 4.55 seconds. If I look at this, see what the maximum speed was here. It looks like 0.815, not quite the same, but if you noticed, both maximum speeds occurred at the exact same time. So that's the data that I'm looking for, and I can record that as well. And then what I'd want to capture here in terms of something I'd want to put and show in my lab report, I'd want to use snip. I already have it down here, but if you type into the lookup tool snipping, okay, you can see the snipping tools will come up, and I will then select new, and I'm going to grab these two graphs for each of my scenarios. Make sure I have the axis labels, right? So time, and you can see the velocity for each. And what that does is gives me a nice image that's copied to my clipboard. I can then go ahead and paste that into a Google Doc and then label which one it was. And everybody in your group can have access to that data and have it for their lab reports. Okay? All right, guys. Hopefully that was helpful, and I'll see you soon.